Hello everybody. Today we're going to be starting a new chapter, and that's on volume. We will hit a couple shapes in the next week. Today we're going to be starting out with two, and that's prisms and cylinders. So first we want to talk about what a prism is. So a prism is a three-dimensional shape that's made of polygons. So a 3D shape made of polygons. Just a reminder, polygons are those closed shapes that are made of segments, so no curved sides. Triangles, squares, trapezoids, pentagons, those are all polygons. Now, there's lots of different kinds of prisms. Here are a couple of them: rectangular prism, triangular prism, trapezoidal prism, and I call it pentagonal, but some people say pentagonal prism. So prisms have a couple different pieces, and we'll go back and fill a couple things in up here as we draw them. So a rectangular prism is going to look like a Kleenex box, a cereal box. It's going to look something like this. So in any prism, you have two vocabulary words that are really important here. The first one is the base. So the base is the congruent and parallel sides. So this will have two bases, which are the congruent and parallel sides. Now in a rectangular prism, I'm actually going to draw this so it looks three-dimensional. In a rectangular prism, the top and the bottom are parallel and congruent, the front and the back are parallel and congruent, and the left and the right are parallel and congruent. So any of those three sets can actually be considered bases. In a triangular prism, however, the triangles, so the first word of the prism, the triangular prism, actually tells you what the base is. So in a rectangular prism, we actually know the bases are going to be rectangles. In a triangular prism, we know the bases are going to be triangles. So when you draw your triangle, unless it specifies what kind of triangle, you could do obtuse triangles, right triangles, isosceles triangles, whatever you want. For this one, I'm going to draw a right triangle. So if my triangles are my parallel ones, then that's gonna need to make sure I only have two of those triangles. Oh, I should make this dashed to show that it's inside of my shape here. So that's approximately a right triangular prism. You could draw a non-right triangular prism as well, as long as the two parallel sides are those triangles. So in a trapezoidal prism, the bases would be trapezoids. All right, if you notice in both of these pictures so far, all of the other sides, the ones that are not the bases, those are called faces. Do you see that they're all rectangles? So let's see if that happens in a trapezoidal prism as well. So in a trapezoidal prism, we would need to start out with a trapezoid. Now I have lots of practice drawing these, so don't stress out if you are struggling. Another way that you can draw them, which is what my mom used to teach me when I was a little kid, is you draw one of your bases, draw the other base, just kind of like up into the right-ish, and then just connect all the corresponding corners, and that will also help you. That'll work for any of these if you just draw them a little offset of each other and then just connect them all. All right, so we know that our bases are going to be the trapezoids. So you can see that every other side, though, is a rectangle. So not only is it going to have two bases, which are going to be parallel and congruent, all other sides, they're called faces, all other faces will be rectangles. So in a pentagonal prism or a pentagonal prism, we need to start off with a pentagon. So I'm going to use the other approach this time, where I'm just going to try to draw the best I can. It needs to be congruent. The best I can, another congruent pentagon. And then I'm just going to connect all of the corresponding bits. These ones that I'm connecting in dashed lines are supposed to be like behind the shape, like we're seeing through the shape. All right, so prism would be three-dimensional shape made of polygons. It's going to have two bases, though they are going to both be parallel and congruent. And then every other face, every other side of your prism is going to be a rectangle. All right, so let's talk about our other one, which is a cylinder. So cylinders, you probably have a really good idea what those are. That's going to be your soup can, your toilet paper roll. It is made of two bases as well, except not polygons. Your two bases are, this time, they are parallel and congruent, but they are circles. Now, something that you may have never considered, though, is the part that like goes around the cylinder is actually a rectangle that's been rolled up. Test it out. Take a piece of paper, roll it up. What shape does it make? That tube shape actually is a cylinder if you put bases on both ends. So it has two bases, which are circles. They're both parallel congruent. And that middle part, it's actually called the lateral face. So these other faces here, which were rectangles in the prism, is the lateral face of a cylinder. It has a rolled rectangle as the middle. All right, so when you draw a cylinder, a lot of times people want to put the circle on top and the circle on the bottom. When you draw the circles, though, to give it some kind of perspective, you're actually going to make them ovals. So that way it looks a little bit more three-dimensional. So I drew like a skinny oval here, two straight lines. I'm going to connect that with a curve, and then I'm going to dash it to the back just so I can show that it's three-dimensional. But you could also draw it this way. Same way, draw your two circles, and then kind of just connect that way as well. All right, so now we have the basic idea of what all of our shapes are, the prism and the cylinder. They're actually kind of similar to each other. They both share bases, right? They both have one set of parallel congruent bases, cylinders and the prisms. What's different is that the bases of a cylinder are not polygons, but the bases in all prisms will be polygons. And they do have a lateral face, which is that stuff that's connecting your bases. The stuff that's connecting your bases in a prism are rectangles. And technically, the stuff that's connecting the bases in the cylinder is also rectangle. It's just one rectangle as opposed to several rectangles. So they do have some things in common. All right, so let's talk about volume now. So what is volume? Volume is the amount of stuff that will fit inside of your three-dimensional shape. The amount of space, the amount of stuff. Now, your shape doesn't need to be a prism or a cylinder in order to have volume. It just has to be three-dimensional, and you can fit stuff inside of it. So like your pillow at home, all the stuffing that's inside, right? How much stuffing would fit inside your pillow? That would be the volume of the pillow. How much water is in your glass? That would be the volume of the glass. So we're looking for how much stuff is going to fit inside. All right, so to figure out how much stuff fits inside of a prism or a cylinder, we actually kind of want to think about it as stacking a bunch of layers on top of each other. So for instance, if we had this prism right here, I'm going to make it look three-dimensional here just a second. We want to figure out how many stacks, how many layers, right, can fit in this entire prism. So if we found the area of just the bottom and then figured out how many times we could stack that all the way up to the top, then that would represent the amount of volume that's inside of my shape. So in this rectangular prism, then if we found the area of the base, which in this case looks like a square or a rectangle, so we find that by base times height, right? So if we found the area of the base, and now when I say base, I mean whatever shape is the base, so the parallel or congruent side. So this could be a rectangle, a triangle, a trapezoid. That means the area formula would change, okay? If we find the area of that and we multiplied it by how many times we could stack that shape. So if I could put another stack here and another stack here and another stack here, all of those stacked up on each other would give us the volume of our entire shape. So then this is going to represent how many times we could stack it. So we're going to call that the altitude. So if I want to find the volume, I'm going to find out how many stacks. So this is like my number of stacks. And the area of my base is just the initial area. So would the same idea work for a cylinder? Well, if we think about a cylinder being a very similar shape, then could we find the area of the bottom circle and then figure out how many times we could stack that circle on top of each other? That would represent our volume. So the initial area, the area of the base, this could be a square, a rectangle, so base times height. It could be a circle, which would be pi r squared, right? If it were a triangle, we would need the formula for a triangle. So you might want to get out your area formula cheat sheet to help you through some of this today. Same thing for a trapezoid. If we found the area of our trapezoid and then how many trapezoids could we stack, that would be our volume. So that's what we're going to be looking at for in the examples on this second page. Okay, so let's go back to the shapes that we drew from before. So if we start with our rectangular prism, we know that the bases are going to be rectangles. And in a rectangular prism, all of the opposite sides are parallel and congruent, so any of those rectangles can represent the base. It doesn't matter which ones. So let's say we think of, I'm going to make this three-dimensional. Let's say we make the front rectangle and the back rectangle the bases, right? So if we're going to do the area of the base, and I'm going to write base in capitals so we know it's the area of the shape. It's not like base times height times the altitude. Now your altitude is the distance between the bases. So that's really important here. It's the distance between your bases. So in order to know your altitude, you have to know what shapes are your bases. So the area of your base could be any of those formulas. So if we're using the front and the back, so the area of my base here would be base times height, because it's a rectangle, right, times the altitude, which is the distance between them. So if I'm using the front and the back, it would be 2 times 3 for the area of my base, and then I would multiply that by 6 for my altitude. So that would give me 6 times 6, which would be 36 feet cubed. So volume, you may remember this from when you learned it. I think you talk about volume in 6th grade, but the units are always cubed. And the reason they're cubed is because literally when people started figuring out how to do volume, they talked about how many cubes would fit inside my shape. That's literally what you're doing. How many cubes will fit inside of my shape? So this one would have 36 because it would have one layer of 3 by 6 on the bottom, and then because this is 2 feet tall, you would have another layer on top of it. So a layer of 18 and a layer of 18 would give you 36. If you wanted to use the bottom as its base, then base times height would be 3 times 6. And then if the bottom and the top are the bases, then the distance between the bases is 2. And that's 18 times 2, which is still 36. So in a rectangular prism, it literally does not matter which set you use as the bases. Now in a triangular prism, it matters because it's a triangular prism, which means we need to use the triangles. So in this case, we're going to use this triangle here. So for the triangular prism, we need to use the triangles. So triangular prism, the area of a triangle is going to be 1/2 base times height, and then we're going to have to multiply that by the altitude, which is the distance between the triangles. So the altitude in this case is going to be 10 because there's 10 centimeters in between our triangles. And then the base and the height, remember, have to be perpendicular. So this 20 is not the base or the height, but we can use that 20 here. And then because it's a right triangle, we can use the Pythagorean theorem to find this side right here, which would be 16. So we're going to have 1/2 base for our triangle, which could be 12, 16 times the distance between our bases, which is 10, which gives us a volume of 960 centimeters cubed. So for our trapezoidal prism, the area of our base is going to be a trapezoid. So we're going to need the formula for that. So that's 1/2 times the height, base 1 plus base 2. And then we're going to multiply that by the altitude, which again is the distance between the trapezoids. So these numbers are kind of small. I probably should have made my picture bigger. But this is supposed to be 10 centimeters. This side right here is 30 centimeters. This right here is 3. And then this guy here at the top is 8. All right, so our bases are the trapezoids, so our altitude is the distance between the trapezoids. So since we have a trapezoid in the front, that means we're also going to have a trapezoid in the back. So the distance between those trapezoids is 30. And then the height of the trapezoid, remember, has to be perpendicular to your two bases of the trapezoid, and your bases are the parallel sides. So our 8 and our 10 are the parallel, so 8 plus 10. And then the height would be 3 of the trapezoid. So now we just got to multiply everything together. And we get for our volume 810 centimeters cubed. Again, don't forget that volume has cubic units. So cubic centimeters, cubic feet. Now, for our pentagonal prism, pentagons are the bases. So we need the area formula for a pentagon, which you may remember, it's been a while since we've done it. 1/2 perimeter times apothem, and then we're going to multiply that by the altitude, which is the distance between the pentagons. So the distance between our pentagons is going to be 3. Our perimeter, so it didn't mark this in the picture, I should have had that already, but this is supposed to be a regular pentagon. So since one side is 4, we're going to multiply by 5 because there's 5 sides, so our perimeter will be 20. And then our apothem is given in our picture is 2.75. So that gives us a volume of 82.5 units. This time are inches cubed. All right, as we move from the prisms into the cylinder, if we remember from our first page over here, the volume of a cylinder is going to be very similar to the volume of a prism. So we're going to do the area of the base. Just this time, our base is not a polygon, it's a circle. So the area of our base times the distance between our bases, which is our altitude. So since our base is a circle, we're still going to do area of the base, which this time will be pi r squared, times the altitude, which don't forget is the distance between the circles, distance between the bases. All right, so in our picture, we already have the radius is 25, so we're gonna have pi times 25 squared, and then the distance between the bases is the distance between the circles, so times 40. This is gonna be a pretty big number. So multiply all this together, we get 25,000 pi. So I'm not actually going to multiply by pi. Don't forget we have 2 ways we can write our answer. This is the exact answer. Don't forget your units. Or if you like the approximate version, we're going to multiply this by pi. And we get, oh, this is a big one, 78,539.82 inches cubed. So either one of those would be fine. Remember, with the pi is exact, this guy right here is approximate. All right, for our last problem, we actually have a composite shape. So when you look at this shape, what do you see? We've got a rectangular prism here on the right side, and we have half of a cylinder here on the left side. So we're gonna find the volume of both of those and add them together. So we're gonna do the volume of the half cylinder, and we're going to add to that the volume of the prism. All right, so it doesn't matter which one we start with. I'm going to just go left to right. So if I start with my half cylinder, so remember it's the area of the base times the altitude. So you might hear the tornado sirens going off. It's the first Monday of the month. So I'm going to try to keep talking. So cylinder is going to be pi r squared, because our base is a circle, times the distance between the circles. So we've got pi r squared, so pi times, and if we look at our picture, this right here is representing a diameter, and it's 4, so its radius would be 2. Times the altitude, which is the distance between those circles, which we can see from over here, would be 8. But I only want half of this cylinder, so I'm going to multiply this whole thing by 1/2. Or if you'd like to divide by 2 instead, that's totally fine. And then my prism, which is over here on the left side, area of the base. Since it's a rectangular prism, any of these sides can represent the base. I'm going to use the bottom as my base. So base times height, 4 times 5. The distance between the top and the bottom is 8. So for my half cylinder, once I multiply all this together, I'm going to get 16 pi. And then for my prism, we're going to have 160. So this is the volume, and this double marks here on this 8 mean inches. So inches cubed, which is approximately. So here's our exact answer. Our approximate answer would be 210.27 inches cubed. All right, if you have any questions about prisms or cylinders and their volume, please reach out to Miss Regal or myself. Otherwise, you have a fantastic day.